Hello guys, welcome to my YouTube channel Anil Physics Academy. In today's video, we are going to solve some problem on dot product and cross product of two vectors from H C VERMA book. The first question is from the chapter 2 of H C VERMA and from page number 29, and the question number is 14. Question says we have to prove that vector A dot in bracket vector A cross vector B is equal to 0. We have to prove this. So let us start solving this problem. See, suppose there are two vectors here, vector A and let this vector B, and let this vector A and B are in the plane of this board. Then what is the direction of when vector A cross B is perpendicular to the plane in which vector A and vector B lie? That is, vector A cross B is perpendicular to the plane of this board because vector A and vector B lie in this plane. So the vector A cross B is perpendicular to this board, that is this way. Vector A cross B, from the right hand thumb rule, vector A cross B is outward this board and perpendicular to it, this. So the angle between A cross B and vector A is 90 degree. So and as we know, if the angle between two vectors is 90 degree, then their dot product is 0. So vector A dot vector A cross B will be magnitude of vector A into magnitude of vector A cross B and cos angle between vector A and vector A cross B. As I have showed you just now that the angle between vector A and vector A cross B is 90 degree, cos 90 degree, and cos 90 has value 0, so this is equal to 0. So we have proved this. Now let us proceed to the next problem. This question is also from page number 29, chapter 2 of H C VERMA book, and the number of question number is 16. What does the question says? The question says, if vector A, vector B, vector C are mutually perpendicular, let there be three vectors. Let this is x axis, this is y axis, and this is z axis. So this z axis is actually this z axis is perpendicular to this plane. X and y are in the plane of this board, and z axis is perpendicular to the plane of board moving outward. Positive direction of z axis is perpendicular to the board and moving out of it. So let here A be this vector A, this be vector B, and this be vector C. According to question, these three vectors are mutually perpendicular, and we have drawn these two vectors on x axis, y axis, and z axis along. So these are perpendicular to each other because the three axes of Cartesian coordinate axes are perpendicular to each other. So the angle between these three vectors, the mutual angle between these three vectors is 90 degree. We have to prove that vector C cross vector A cross vector B is equal to 0. See, what is the direction of vector A cross B? From the right hand thumb rule, we align our forefinger along vector A and we curl them around towards vector B. The thumb gives the direction of vector A cross B. So our thumb point in perpendicular to this board, that is along Z axis. Our thumb points along Z axis, that is in the direction of vector C. So the direction of A cross B and direction of vector C are the same. So the magnitude of this, magnitude of C cross vector A cross vector B is equal to magnitude of vector C into magnitude of vector A cross vector B and cos and sine 0 degree, because the direction of vector C and vector A cross B is same as I have just shown you, and sine 0 has value 0, so this is equal to 0. So if three vectors are mutually perpendicular, then their cross product, then if A, B, C are mutually perpendicular, then vector C cross vector A cross B is equal to 0. And in this question it is also asked that is the converse is true. It means if this is 0, it means they are mutually perpendicular. Let us see. Suppose that B is not along here, but let B it here. So B is not along y axis, but B is along xy plane. It is not along y axis, but still it is in xy plane, in the plane of board. So now if you calculate vector A cross B vector C, then also we get result 0. Why? Because A cross B has direction in Z axis from the right hand thumb rule. We point 4 of my fingers along A and curl them around B. My thumb points towards A cross B, which is along C. So in this also the vector A cross B and vector C has angle 0 between them. So in this case also, when the B is not along y axis, that is 3 are not perpendicular, the vector C cross vector A cross B is equal to 0. So converse is not true. It means if three vectors have vector C cross vector A cross vector B is 0, then it is not necessary that three of them are in perpendicular direction, mutually perpendicular direction. Let us proceed to the next problem. This problem is also from page number 29, and the question is question number 19. The question says, give an example for which vector A dot vector B is equal to vector C dot vector B, but vector A not equal to vector C. Let us take an example of this. Let there be B vector, this is B vector, and this is A vector which is perpendicular to vector B, and this be the C vector. As we can see, A and C are different in magnitude and directions, so they are different vectors. So angle between C and B is also 90 degree. So if we calculate vector A dot B, then it is magnitude of A, magnitude of B, and cos 90 degree is equal to 0. Now we compute, if we compute vector C dot B, then this is equal to magnitude of C, magnitude of B, and cos 90 degree. Cos 90 degree has value 0, this is also 0. So here we can see that vector A dot B is equal to vector C dot B, but the vector A and C are not equal. So this is an example when vector A dot B is equal to vector C dot B, but vector A is not equal to vector C. So guys, that's all for today. Thank you very much.